Welcome everyone. In this lecture, we are going to discuss about the construction materials and management. So let me start with structural steel. In order to reduce the work involved in design computations to facilitate the use of Indian Standard Code of Practice for the use of structural steel in general building construction. The code is IS Indian Standard 800 2007. It is proposed to make available a number of design handbooks showing typical designs of different types of structures. Structural steel, it can be in the form of rolled steel beam, channel sections, angle sections, sheets, bars, squares, flats, and plate thin bars. A number of design codes are available according to the shape of the structural steel member. So coming to the composition of structural steel, steel is an alloy of iron, carbon, chromium, nickel and many other elements. So some of the important chemical elements used in structural steel are carbon. Carbon is one of the important chemical element in steel. Why means if the carbon content in the alloy is increased to a certain level, then strength increases, but ductility decreases. Structural steel have the carbon content between 0.15 to 0.3%. If the carbon content much higher, the ductility will be very low. Carbon is inversely proportional to the ductility. If carbon content increases, ductility decreases. Next, coming to the manganese. Manganese has a percentage ranging from 0.5 to 1.7%. It has effects similar to carbon. Next, coming to aluminium. Aluminium is used as a deoxidizer in the material. It helps to form a more fine-grained crystalline microstructure. Next, coming to chromium. Chromium is primarily used to increase the corrosion resistance of the material. Next, coming to copper. Copper is under primary corrosion resistance elements. So here chromium and copper is the two important elements in structural steel which are used to increase the corrosion resistance. Next, silicon. Along with aluminium, silicon is the one of the principal deoxidizers for structural steel. It normally appears in amount less than 0.4%. Now, so we discussed about the structural steel composition. Here mainly we can see that carbon content ranges from 0.15 to 0.3%. Here carbon is inversely proportional to ductility. Carbon is content increases, ductility decreases. Next, coming to manganese, it ranges from 0.5 to 1.7%, whereas silicon it is less than 0.4% and copper is greater than 0.2%. That means it is not less than 0.2%. The copper and chromium are the two elements which are called as anti-corrosion components. So that's all about the composition of structural steel. Now we'll be discussing about the material properties of steel design. Generally, Properties of the steel depends upon its chemical composition, method of manufacturing, and the process of fabrication. It mainly depends upon chemical composition, we can say. So some of the important properties of steel we are going to discuss here. The first one is the strength. Whereas if you see that the structural steel component has mainly tensile strength, whereas if you see concrete, it will be having compressive strength, whereas steel is having tensile. So there is a difference between the steel and concrete. If you try to compare the strength, tensile strength of a steel member increases with increased hardness of the material. Next, coming to the toughness. Toughness is the resistance to the impact loading against fracture. So we can say simply it is a resistance to the impact loading against fracture. Whereas strength is the ability of a material to resist failure, whereas toughness is the impact loading against fracture. This is the main difference between the strength and toughness. Toughness is in the nature of all material contain some imperfections. In steel, these imperfections take the form of very small cracks. If the steel insufficiently tough, the crack can propagate rapidly without plastic deformation and results in a brittle fracture. The toughness of steel and its ability to resist brittle fracture are dependent upon a number of factors that should be considered at the specification stage. So we can see that here toughness is the resistance to the impact loading against fracture, whereas the strength is the ability of a material to resist failure, whereas the stability, it is the ability of a material to resist deformation. So whereas failure is strength, deformation is about stability, whereas about the toughness is about the impact loading against fracture. Next, we will discuss about the ductility. Ductility is a measure of the degree to which a material can be strained or elongated between yield point to the fracture point under the effect of tensile loading. So we can say simply, with increase in carbon content of the steel, its strength increases but ductility decreases. So ductility is measured in tension test by percent elongation over a given gauge length, usually 2 or 8% reduction of cross sectional area. So ductility is inversely proportional to the tensile strength. Ductility is an important property because it permits redistribution of stresses in continuous members and at points of high local stresses. So this is all about the ductility. Now we'll discuss about the durability. So durability is one of the important primary factors that influence the material properties of the steel. The durability is defined as the ability to withstand wear and tear through weathering and corrosive attack, etc. The increased distortion of planes and structures decreases the corrosion resistance of the material. So simply, durability is the ability of a material to withstand for wear and tear and corrosive attack. These are about the material properties of the steel design. The material properties of steel design. So some of the properties important that are considered in designing of steel members or first one is modulus of elasticity. For standard structural steel member, the modulus of elasticity can be taken as 2.1 into 10 power 5 Newton per mm square. This Newton mm square is also called as a megapascal. Next, another factor is shear modulus. Shear modulus is also called as modulus of rigidity, that is denoted by symbol Z. We have one formula, Z is equal to E by 2 into 1 plus mu. Here E stands for modulus of elasticity, mu stands for Poisson's ratio. For a structural steel, the modulus of rigidity, that is shear modulus, is taken as 8.1 into 10 power 5 Newton per mm square, whereas the Poisson's ratio of structural steel is 0.3. And coming to coefficient of thermal expansion denoted by alpha, in the ambient temperature range it will be 12 into 10 power minus 6 per degree centigrade. So these are the some important factors that will be considered in the steel design: modulus of elasticity, shear modulus, Poisson's ratio, coefficient of thermal expansion. Next, we will discuss about bricks. Clay bricks are used for building of exterior and interior walls, partitions, piers, footings, and other load-bearing structures. A brick is a rectangular in shape and of size that conveniently handled with one hand. It is made of burnt clay and mixture of sand and lime of Portland cement concrete. The length, width, and height of brick that may be taken as: generally the length of brick is 2 into width of brick plus thickness of mortar. Height of brick is nothing but the width of the brick. Generally the bricks having the standard size that should be 19 into 9 into 9 centimeters. When a masonry is placed in between the brick, the size becomes 20 into 10 into 10 centimeters. This is the one of the important factor we should know. The size of the standard brick is 19 into 9 into 9 centimeters, but when mortar placed, the size becomes 20 into 10 into 10 centimeters. So here we can see the composition of brick. So these are the composition of brick. Here we see alumina is in the combination of 20 to 30%, silica 50 to 60%, lime that is less than 5%, magnesia 0.1%, iron oxide 5 to 6%. The clay should be free from pebbles, gravels, alkalis, organic matter, vegetation and iron pyrites. Another thing is that an indent called frog. Frog is 1 to 2 centimeter deep, is provided for 9 centimeter high bricks. The size of frog should be 10 into 4 into 1 centimeter. The main purpose of providing frog is to form a key for holding the motor, and therefore the bricks are laid with the frogs on top. So now we'll discuss about the requirements of bricks. Generally, clay bricks are having the more requirement. Generally, the color of brick is red copper and uniform. The edges should be sharp, free from organic matter and remaining salts. There should be metallic ringing sound. What is the importance of the bricks means? Mainly, I told you in the previous only. Mainly it is used for building up exterior and interior walls and partition walls for piers, footings, and other load bearing structures. So generally in lintel and column construction also they are mainly preferred because they are very lightweight. Clay products, hence eco-friendly, cheap and easily available. These are all about the requirement and importance of the bricks. Now here you can see that types of bricks. Generally there are two types of the bricks. One is the conventional or traditional bricks. Another one is the standard bricks or modular bricks. If you see the conventional bricks, the size is 23 centimeters into 11.4 centimeters into 77.6 centimeters, whereas the standard brick size is 19 into 9 into 9 centimeters. I told you in the previous only, for the standard brick, that is a clay brick having the 19 into 9 into 9 centimeters, but when mortar is placed in between the bricks, the brick size becomes 20 into 10 into 10 centimeters. So according to manufacturing, bricks are classified as two types. One is the hand molded, second one is the machine molded. Whereas based on the quality and utility, bricks are classified as four types. First class, grade A, second class, grade B, third class, grade C, fourth class, grade D. So that's what we have discussed. What is the use of the bricks? Bricks are used in exterior and interior walls, which is used in masonry construction of building. Bricks are used in brick lintel construction, and still bats of bricks are used in concrete in foundation work like pier foundation and footings. These will be used. Coming to the properties of bricks, that is physical properties, mechanical properties, thermal properties, and durability. So if you see the physical properties, that is shape, size, color, density, whereas mechanical, compressive strength and flexural strength. Whereas thermal, it is heat insulation, sound insulation. Coming to durability, porosity, water absorption. These are the some of the properties of the brick. Generally, the test the perform on the bricks are, one of the important is the water absorption test. According to Indian standard 349, according to Indian standard 3495 part 2, dry bricks are put in and woven at a temperature of 105 degrees centigrade to 115 degrees centigrade till this attain constant mass. The average water absorption shall not be more than 20% by weight up to class 12.5 and another test performing on brick is the dimension test. According to Indian standard 1 2077, this test is performed. 20 pieces out of selected pieces are taken and laid flat. The tolerances and the sizes of bricks are fixed by giving minimum and maximum dimensions. It follows this method of measurement. The batches are likely to contain bricks outside the prescribed limit of tolerance. Whereas another test is the efflorescence test according to Indian standard 3495 part 3. So these are the three important tests: dimension test, water absorption test, efflorescence test, which is performed on the mainly on the bricks. These are all about the bricks. Next we are discussing about the lime. Lime is a calcium containing inorganic mineral composed primarily of oxides and hydroxide. It is also the name for calcium oxide, which occurs as a product of coal seam piles. The requirements of good lime is moisture resistant, provide good plasticity and workability, not contain any impurities. Lime can be set easily, flake easily with the water, and lime should have low shrinkage. So these are the requirements of good lime: moisture resistant, flake easily with water, good plasticity and workability. Workability, it is one of the homogeneous property. Next, properties of lime. Generally, lime possesses good plasticity, good workability, and good adhesion with masonry. Lime stiffens, lime stiffens quickly, and lime is good resistance to moisture, and lime is having very low shrinkage. There are three types of lime: hydraulic lime, fat lime, and poor lime. So hydraulic lime is one of the important lime that we use as a combination for mortar. You see the importance of lime. Lime is a cementing material. It provides a cheap and reliable alternative to cement. Cement is used as a binding material, and also lime is also used as a binding material. Lime is used to bind sand to prepare a lime mortar for masonry work. Lime is important to prepare bricks, bat lime concrete for foundation of buildings. Now we'll discuss about the one of the important material, artificial material, that is cement. Cement is a product obtained by burning a well proposed mixture of siliceous, argillaceous, and calcareous materials and crushing the same into the grey color fine powder. The ingredients of cement are silica, which provides strength, and lime, which provides strength, alumina, that makes the cement quick setting, iron oxide, that provides color, hardness, and strength, magnesia, that provides hardness and color, and calcium sulfate, which is called as gypsum, increases the initial setting time. If you see the manufacturing of cement can be done in two methods: dry process and wet process. If you see the wet process, there are many stages. mixing of raw materials, burning in rotary kiln, grinding in ball mill and tube mill, packing in jute or gunny bags, and storage. Next, we'll discuss about the testing of cement. The most important tests that are conducted on the cement in the laboratory are as follows: fineness test, consistency test, setting time test, strength test, heat of hydration test, and tensile strength test, and chemical composition test. First, let me discuss about the fineness test of cement. The fineness test of cement is responsible for the hydration, rate of evaluation of heat, and the rate of gain of strength. This fineness of test can be determined by sieve test or air permeability test. Sieve test, the residue left on the sieve is should not exceed 10% of ordinary cement. Another test is performed by fineness is air permeability test. This is called as a Blaine's air permeability test. It is used to find the specific surface, which is expressed as the total surface area in square centimeter per gram of cement. So these are the two important tests we performing for find out the fineness of a cement. One is the sieve test, another one is the air permeability test. In the sieve test, the residue lefting should not exceed 10% of ordinary cement, and air permeability, which is Blaine's air permeability test, to find out the specific surface. Next, we'll discuss about the standard consistency test. This test is conducted to find the setting time of cement using a standard consistency test operator, that is Vicart operators. It is the important thing here. Vicart operators. This Vicart operators is used to find out the setting time of, that is standard consistency. Standard consistency can be checked. This test should be conducted at a standard temperature of 25 to 29 degrees centigrade. Standard consistency of a cement paste is defined as that water content which will permit a Vicart plunger of 10 mm diameter and 50 mm length to penetrate depth of 33 to 35 mm within 3 to 5 minutes of mixing. Simply we can say that a Vicart plunger of 10 mm diameter and 50 mm length to penetrate depth of 33 to 35 mm within 3 to 5 minutes of mixing. This is nothing but the standard consistency test. This test is performed at 25 to 29 degrees centigrade. Next, we will discuss about the setting time of test, which is performed by using the Vicart operator. Generally, there are two types of the setting. One is the initial setting time and final setting time. Initial setting time is the needle is allowed to penetrate into the paste. It is nothing but the initial setting time. The time taken to penetrate 33 to 35 mm depth is recorded as the initial setting time. Whereas the final setting time, after the paste has attained hardness, the needle does not penetrate the paste more than 0.5 mm. Time at which the needle does not penetrate more than 0.5 mm is taken as the final setting time. Next, we'll discuss about the soundness test. This test is conducted by Lee Chartlier operators. Lee This test is conducted in Lee Chartlier's operators to detect the presence of uncombined lime and magnesia in cement. So this is one of the important tests, and we'll discuss about the tensile strength of cement, that is the strength of test. This test is carried out using a cement mortar briquette in a tensile testing machine. A 1 is to 3 a 1 is to 3 a 1 is to 3 cement sand mortar with the water content of 8% is mixed and molded into briquette in the mold. This mixture is cured for 24 hours at a temperature of 25-29 degrees centigrade in an atmosphere at 90% relative humidity. The average strength for 6 briquettes tested after 3 days and 7 days is recorded. So this is the one of the important tests, tensile strength of cement. Next we will discuss about the heat of hydration test. During the hydration of cement, heat is produced due to chemical reaction. This test is carried out using a calorimeter, adapting the principle of determining heat again. It is concluded that low heat cement should not generate 65 calories per gram of cement in 7 days and 75 calories per gram of cement in 28 days. So this is one of the important tests, heat of hydration test carried out using a calorimeter. Next we will discuss about the chemical composition of test. This chemical composition test is conducted by different tests to determine the amount of various constituents of cement. The ratio of percentage of alumina to the iron oxide should not be less than 0.66. Generally, according to Indian standard 269 1998, it follows the chemical composition test. Here, the weight of magnesia should not be greater than 5%. Total sulfur content should not be greater than 2.75%. So these are the major laboratory tests. First one is the standard consistency test, that is used by the Vickert apparatus. Fineness test is performed by two tests, one is sieve test and lens air permeability test. Soundnet test is performed by Lee Charter apparatus, and strength test by combination of cement and sand. The motor 1 is to 3 ratio by using 6 briquettes. It can be performed. Heat of hydration test by using the calorimeter, and then chemical composition by using the Indian standard 269 1998. It follows. Coming to the field test of cement, majorly we detect that following test. One is the color test of cement. The color of cement should not be uneven. Generally, it should be uniform gray color with a light greenish shade. So the color of the cement should not be uneven, and it should be a uniform gray color with a light greenish shade. That is the color of a cement, whereas the cement should not contain any hard lumps. Lumps are formed by absorption of moisture content from the atmosphere. The cement should be smooth if you rub in between fingers. If not, then it is because of alteration of sand. So these are about the testing of cement. Standard consistency test, Vickot apparatus, fineness is sieve test, soundness is recharge clear, heat of hydration is the calorimeter. This is one of the important tests that is performed. Initial setting time and final setting time is also performed by using the Vickot apparatus. That is the important test we discussed here. Next, we'll discuss about one of the important material, concrete. Concrete is a composite man-made material. It is the most widely used material in the construction industry. It consists of a rationally chosen mixture of binding material such as lime or cement, well-graded fine and coarse aggregates, water and admixtures. Concrete is a mixture of cement or lime, sand, crushed rock, that is nothing but the coarse aggregate, and water. In a concrete mix, cement and water form a paste, which is addition to filling the voids of the fine aggregates. Freshly mixed concrete before set is known as the green concrete, whereas after setting and hardening is known as the hardened concrete. In the preparation of concrete, the ingredients are cement, sand. Sand is nothing but the fine aggregate, and coarse aggregate is nothing but the gravel and water. There are mainly two methods of mixing of concrete. One is the hand mixing and the machine mixing. If you see the importance of concrete, prepared at project site under supervision and fabricated, the concrete solidifies and hardens, attaining greater strength with age. They are strong and durable.